Usually when we talk about a medical diagnosis, there is this comforting expectation of precision, I guess. Like it feels almost like engineering.
Oh, totally. Like you break your arm, they take an X-ray, and
Right, the doctor just points at that jagged white line on the film and says, there it is, that's the problem.
it's wonderfully binary. I mean, a bone is broken or it isn't, right?
Mm-mm.
The visual evidence just leaves very little room for interpretation.
Yeah, we really like things to be visible and neatly categorized, but the moment you step into the world of mental health, and especially mood, that X-ray machine just totally shatters. We are suddenly looking at a diagnostic landscape that is, incredibly murky.
Yeah, murky is a great word for it.
And for decades, we've all been sold this very tidy, very appealing narrative to kind of compensate for that murkiness. Like, if you've ever taken a high school biology class or, watched a drug commercial on TV, you know exactly the story I'm talking about. You have a quote-unquote chemical imbalance.
Right. It's that really pervasive idea that your brain is just running a little low on the happy chemicals, and you just need to take a pill to top up the tank.
Which sounds so clean and logical, but here is the bombshell we're dropping today. The scientific community is actually actively walking back that popular narrative. It turns out that simple chemical imbalance story is a drastic oversimplification of how human emotion actually operates.
It really is. It's almost entirely a myth at this point.
So today we're going on a deep dive into the real brain chemistry of feelings. We're looking at a fascinating stack of sources to do this, including a landmark 2022 umbrella review, FDA Freedom of Information Act data, and some pretty brilliant historical studies just to completely dismantle everything we thought we knew about this topic.
Yeah, we've got a lot of ground to cover.
We really do. We're going to unpack how neurotransmitters actually shape your mood, explore the cutting-edge science that's redefining mental health, figure out what is really happening inside our heads.
And, to set the stage, since we're tossing out that simplistic middle school version of brain chemistry, we should probably clarify the cast of characters we're dealing with here.
Yeah, that's a good idea. Give us the roster.
So we've always pictured neurotransmitters just jumping the synaptic gap to flip a happy or sad switch. But they are actually part of a highly complex communication network. We'll be looking at the famous monoamines, so that's serotonin, dopamine, norepinephrine.
The ones everyone has heard of.
Exactly. But we also have to bring in the heavy lifters of the brain's daily signaling, which are GABA and glutamate, along with a growing list of neuropeptides and stress hormones like cortisol. Because, they all modulate your emotional state in ways we are honestly only just beginning to map out.
Okay, let's unpack this. Because before we can understand how the brain actually works, we need to understand how we got this chemical imbalance narrative in the first place. And the origin story is frankly wild.
It really is. It wasn't some genius scientist looking through a microscope and having a eureka moment about depression.
Not at all. It was the result of two complete medical accidents in the 1950s.
Yeah, what's fascinating here is that the entire foundational theory of modern psychopharmacology was reverse engineered from side effects. So in the early 1950s, doctors were prescribing a drug called reserpine to treat high blood pressure.
Okay.
And, the patient's blood pressure came down, but a significant fraction of them developed severe, sudden depression. Like some even became suicidal.
Oh, wow, just out of nowhere.
Right. And researchers eventually realized reserpine was disrupting the storage of monoamines, meaning it was actively depleting the brain of serotonin, dopamine, and norepinephrine.
So you literally drain the tank and people crash into severe depression.
Exactly. And then there was a second accident happening right across the medical field at the exact same time. In 1952, physicians were treating tuberculosis patients with a completely different drug called iproniazid.
And these were people who were very physically sick, right?
Yeah, physically ravaged by tuberculosis, still very sick in their hospital beds, yet they became unusually euphoric. Like, contemporary medical reports actually described these gravely ill patients literally dancing in the hallways of the hospital.
Which had to be incredibly confusing for the doctors treating them.
Oh, completely.
I know the sources point out that iproniazid was inhibiting an enzyme called monoamine oxidase, or MAO, and this enzyme's normal job is to just break down those monoamines and clear them out, right?
Yeah, it's like the brain's janitor.
So by inhibiting the cleaner upper, the drug caused serotonin and dopamine to rapidly pool and just build up in the brain.
Right, and that buildup created the euphoria. So the medical community looked at these two isolated accidents and drew a seemingly logical but ultimately catastrophic conclusion. You deplete the monoamines, people get depressed. You boost the monoamines, people get euphoric. Therefore, depression must simply be a lack of monoamines.
It's deeply flawed logic, though. It's like noticing that putting air in your tires makes your car drive smoother and reverse engineering the assumption that your engine must run on air.
That is a perfect analogy.
Like you are observing an external fix and just assuming it's the core mechanical cause of the problem.
Right, but that flawed assumption became the absolute bedrock of psychiatry. In 1965, Joseph Schildkraut formalized this exact idea into the monoamine hypothesis of depression.
And the culture just ran with it.
Oh, it reached a fever pitch, especially in 1987 when the FDA approved Prozac. It was designed specifically on this premise. Its commercial success, combined with Peter Kramer's 1993 book, Listening to Prozac, cemented the serotonin imbalance idea into the public consciousness forever.
But the reality check we have today is staggering, because we now have decades of rigorous data to look back on. I want to bring up that landmark 2022 Umbrella Review by psychiatrist Joanna Moncrief.
Yes, the one in molecular psychiatry. That was a huge moment.
It really was. This wasn't just a single trial. I mean, they looked at basically everything we have: blood levels, cerebrospinal fluid, the genetics of the serotonin transporter, the density of the receptors themselves.
They cast a massive net.
Right. And if the chemical imbalance theory was true, they should have found a glaring deficit of serotonin activity in depressed people. But they found absolutely no consistent evidence that depressed people have lower serotonin activity than non-depressed people.
The evidence simply never supported a direct causal story. The serotonin tanks of depressed people are not reliably empty. Now, to be fair, that doesn't mean neurotransmitters are irrelevant or that SSRIs don't help people, but it means the relationship is infinitely more complex than that low chemical, low mood equation we've been operating under.
Here's where it gets really interesting, though. If we completely abandon the idea that low serotonin causes depression, we run headfirst into a massive logical contradiction.
It's a delay problem.
Exactly. Why do drugs that boost serotonin, like SSRIs, actually help millions of people? We know they have efficacy for a lot of patients.
Yeah. Right, and this leads us to one of the most revealing puzzles in pharmacology. Let's look at the basic mechanism. A neuron releases serotonin into the gap to signal the next neuron, and then a transporter mechanism pulls it back into the sending neuron to be recycled.
That's reuptake.
Yes. SSRIs block that transporter. They plug the drain, essentially, leaving more serotonin floating in the gap.
And based on the pharmacology, that blockade happens incredibly fast, right?
Almost immediately. Within hours of taking that first pill, you have significantly increased synaptic serotonin. But here's the glaring contradiction. If depression were just too little serotonin, and you've now flooded the brain with it, the patient should feel better that afternoon.
But they don't.
No, they don't. Clinical improvement in mood typically takes a grueling 2 to 6 weeks.
So if it's not a quick fix, are we talking about structural changes? Like, is the brain physically rewiring itself over that month-long period?
That's exactly what the current science points to.
Because if you don't feel better instantly, it completely shatters the insulin for diabetes misconception. We clearly aren't just filling up an empty gas tank. It feels more like we're planting a garden.
Oh, I like that, planting a garden.
Yeah, like we're putting the seed in the dirt with that first pill, but we have to wait weeks for new roots to actually grow and establish themselves.
That analogy captures the modern neuroscientific view perfectly. The delay problem pushed researchers to look downstream of the serotonin itself. In the 1990s and 2000s, scientists like Ronald Duman at Yale proposed that antidepressants don't work by just topping up a chemical.
So what are they doing?
The initial flood of serotonin acts as a catalyst for a much slower cascade of changes, specifically neuroplasticity.
The brain's capacity to form entirely new synaptic connections.
Yes, the sustained increase in serotonin seems to trigger the release of vital growth factors, most notably BDNF, or brain-derived neurotrophic factor. Think of BDNF as high-grade fertilizer for that garden you mentioned.
So it's actively helping things grow.
Right, it helps damaged, shriveled neural circuits rewire themselves. In animal studies, this process even promotes neurogenesis, the actual birth of brand new neurons in the hippocampus, which is a brain region critical for learning and memory that often physically shrinks during severe, prolonged depression.
Wow. So what does this all mean? It means serotonin isn't a simple happy switch. It's more of a signaling flare that tells the brain to start a slow, structural rebuilding process.
And part of that rebuilding involves the receptors themselves adapting. Over those weeks, the serotonin receptors actually down-regulate. They reduce their own sensitivity or numbers because the system is flooded. The brain is literally remodeling its own architecture in response to the drug.
Okay, so if the serotonin system is basically this slow-acting garden that takes weeks to grow, what is driving our day-to-day, minute-to-minute shifts in mood? Because if we are looking for a chemical that makes us feel good right now, we usually turn to the other famous neurotransmitter, dopamine.
Ah, the classic pleasure chemical.
Right. But I'm guessing we have to dismantle that misconception too.
I'm afraid so. Calling dopamine the pleasure chemical misses its true function almost entirely.
Wait, is this the monkey juice studies?
Yes, the brilliant work of neuroscientist Wolfram Schultz in the 1990s.
I remember this from the sources. He found dopamine didn't actually spike when the monkey got the juice, but rather before it got the juice.
Exactly. He recorded individual dopamine neurons in monkeys as they learned to associate certain cues, like a light turning on with a reward, like a squirt of apple juice. And what he discovered fundamentally changed neuroscience.
What did he find?
He proved dopamine tracks something called reward prediction error.
Let's break down the mechanics of that. It's about expectation.
Right.
Precisely.
If a monkey is just sitting there and suddenly gets a totally unexpected squirt of juice, the dopamine neurons fire rapidly, a huge spike.
Yeah.
The brain is saying, wow, an unexpected good thing happened. Pay attention to this.
Okay, makes sense.
But once the monkey learns the pattern, the light turns on, and 2 seconds later the juice arrives, the timing of the spike shifts.
The dopamine spikes when the light turns on, not when they drink the juice.
Yes, the dopamine fires in anticipation. And when the juice actually arrives exactly as predicted, the dopamine neurons stay completely flat.
Wait, really? There is no chemical reaction to the actual consumption of the reward?
Men. And here is the truly fascinating part of the mechanism. If the light turns on, the monkey gets the dopamine spike of anticipation, but then the researchers withhold the juice.
Oh, the monkey gets nothing.
Right, the dopamine neurons actually dip dramatically below baseline. The brain actively punishes the unfulfilled expectation.
Mind-blowing. So the brain doesn't reward you for getting the thing you like. It rewards you for figuring out that you are going to get it.
Exactly.
So if we connect this to mental health and apply this to you, the listener, what does a dopamine issue actually look like in human depression? Because the sources note that the actual feeling of pleasure, the liking of the juice, relies more on the brain's opioid and cannabinoid systems, according to researchers like Kent Berridge.
Yeah, Berridge made a really crucial distinction there.
So if dopamine isn't pleasure, what is a dopamine deficit doing to our mood?
It reframes dopamine as the primary driver of motivation, of craving, of wanting rather than liking. It's the chemical that makes you get off the couch to pursue a goal. And when you understand this, it perfectly explains one of the most debilitating core symptoms of depression, anhedonia.
If you've ever felt that profound apathy where you just can't get off the couch, that's not sadness. That's your prediction error system failing to signal that getting up is worth it.
It is the total loss of interest and motivation. If your dopamine system is dysregulated, you don't necessarily lose the physical ability to enjoy a good meal or a warm hug. You lose the anticipation that the meal or the hug will be good.
You lose the drive to seek them out.
Exactly. You don't believe the juice is coming, so you stop trying to get it.
That distinction between wanting and liking changes everything. Okay, so monoamines like serotonin and dopamine are these slow-acting catalysts for rewiring or signals for motivation. But they aren't the majority of the brain's activity, are they?
Not at all.
Because if they only make up a tiny fraction of our synapses, we must be missing the main communication lines here.
Yeah, serotonin and dopamine get all the cultural spotlight, but they aren't doing the heavy lifting of day-to-day, millisecond-to-millisecond brain signaling. That job belongs to 2 entirely different neurotransmitters, GABA and glutamate.
We should definitely define these two, because they operate on a much more direct level. GABA is the brain's main inhibitory neurotransmitter, right?
Yes, it turns the volume down, calming the nervous system. When people take fast-acting anti-anxiety medications like Valium, they are directly enhancing GABA's calming effects.
And on the opposite end of the spectrum, we have glutamate.
Right. It is the brain's main excitatory neurotransmitter. It turns the volume up, facilitating fast signaling and learning. And focusing on glutamate has actually led to one of the biggest recent breakthroughs in psychiatry.
You're talking about the ketamine breakthrough.
Yes, which totally disrupted the slow garden theory we were just talking about. A landmark 2000 study out of Yale by Robert Berman and his colleagues looked at ketamine, which operates as a glutamate NMDA receptor antagonist.
Okay, we need an ELI5 on that mechanism. What is an NMDA receptor and what does an antagonist do to it?
Sure. Think of the NMDA receptor as a highly secure gatekeeper for electrical signals in the brain. It controls how neurons strengthen their connections.
Okay.
An antagonist is a chemical that wedges itself into that gate and jams it closed. When ketamine blocks these NMDA receptors, it acts like a circuit breaker. It momentarily stops the normal flow, which triggers the brain to release a massive rebound surge of glutamate.
So it's like building up pressure and releasing it.
Exactly. This sudden excitatory flood instantly forces the creation of new synaptic connections.
Wow. So instead of waiting weeks for BDNF to slowly grow new roots, ketamine forces a rapid structural reset.
Yes. Berman's study showed that this could relieve severe depression symptoms in some treatment-resistant patients within hours.
Not weeks, hours.
Hours. A drug that barely touches serotonin was vastly outperforming SSRIs in speed, which eventually led to the 2019 FDA approval of the nasal spray version, esketamine.
But this raises an incredibly important question, and I have to challenge the premise here for a second.
Okay, go for it.
With all this immense complexity, serotonin rewiring, dopamine prediction errors, glutamate excitation, how much of traditional antidepressant success is actually just the placebo effect?
Oh, this brings us to one of the most fiercely debated, almost taboo topics in modern psychiatry. You have to look at Irving Kirsch's work.
Right, the 2008 analysis.
Yeah, he published a widely cited, highly controversial analysis using FDA trial data that he actually had to obtain via the Freedom of Information Act.
Because he specifically wanted to look at the unpublished trials, right? The trials where the drug failed, which the pharmaceutical companies legally didn't have to voluntarily publish in medical journals.
Exactly. And when he aggregated all the data, the good, the bad, and the hidden, he found something really alarming. For patients with average severity depression, the gap between how much the drug helped and how much the sugar pill placebo helped was statistically significant, meaning there was a measurable difference.
Right.
But arguably, it was incredibly small in clinically meaningful terms. A massive portion of the benefit patients experienced showed up in the placebo arms of the trials as well.
Wait, if Irving Kirsch is right and a massive portion of the benefit is just the placebo effect, how did the FDA approve these drugs in the first place? Doesn't a pharmaceutical company have to beat a placebo decisively to prove their drug actually works?
Well, they do have to beat it, but the threshold for beating a placebo in a clinical trial hinges on statistical significance, not necessarily a huge leap in the quality of the patient's daily life.
Oh, I see.
Yeah. If a drug reliably improves mood by 2 points on a 50-point scale compared to a placebo, it clears the statistical hurdle for approval, even if the patient barely notices the 2-point difference.
So it's technically better, but barely.
Right. The expectation of getting better, the ritual of taking a pill, the therapeutic relationship of being cared for in a medical trial, these psychological factors were doing a staggering amount of the heavy lifting.
Which perfectly ties into this other fascinating phenomenon the sources mention, which Peter Kramer called cosmetic psychopharmacology.
Yes. Kramer noticed that some people without any diagnosable depression took Prozac and reported feeling better than well.
Like they felt more confident, more socially bold.
It completely blurs the line between treating a biological illness and chemically enhancing baseline personality traits. I mean, if the drug is just rewiring circuits and changing how you process environmental stress, it might make anyone feel a bit more resilient, regardless of whether they had a chemical imbalance to begin with.
Wow. Okay, we have taken a sledgehammer to the popular myths today. We've replaced the simple chemical imbalance with neuroplasticity, dopamine prediction errors, the glutamate system, and the powerful psychology of placebos.
It's a lot to wrap your head around.
It is. But let's pull this all back to you, the listener. Why does this deep scientific debate actually matter to your daily life? Like, it's not just an academic argument. How we view this science dictates how we view our own minds and our agency.
Absolutely. And if we connect this to the bigger picture, we have to recognize the original, well-meaning intent of the chemical imbalance story.
They're trying to do a good thing initially.
Right. The idea was to reduce cultural stigma. The medical community wanted to tell people this isn't a moral failing. You aren't weak. It's a biological illness, just like diabetes, and you just need insulin.
But the sources show that strategy backfired terribly. Because when patients take a psychiatric pill and it doesn't work like a simple light switch, they feel uniquely broken.
Yeah. If a doctor tells you it's a simple missing chemical and the chemical doesn't fix it, the natural reaction is despair.
Furthermore, framing mental illness as purely immutably biological can make people incredibly pessimistic.
They begin to feel powerless, as if they are a prisoner to their own fixed chemical destiny. It really minimizes the immense impact of their environment, their trauma, or their daily habits.
Because the truth is, neurotransmitters are just one node in a vast multi-level system. The sources talk extensively about allostatic load.
Right, which is the cumulative physical wear and tear on your body from chronic ongoing stress. Your lived experience literally dictates your brain chemistry.
How so?
Well, your body has a central stress response system called the HPA axis, the hypothalamic pituitary adrenal axis. When you are chronically stressed, say from a toxic job, financial panic, or lack of sleep, that axis pumps out the hormone cortisol.
And what does cortisol do to the brain?
We now know mechanistically that chronically elevated cortisol actively suppresses BDNF activity.
Oh. So chronic stress literally stops the production of the fertilizer. The neurogenesis stops, the synapses wither, and the garden dies.
Exactly. Your environment is reaching into your brain and altering the physical structures. Your mood isn't a fixed genetic destiny. The brain and the body are constantly in a dynamic conversation with everything you do.
I think that complexity is actually incredibly empowering, though.
I completely agree.
I mean, it means your mood interacts with how much sleep you get, whether you move your body, the cognitive behavioral therapy you do, and the social support network you lean on. You aren't just waiting on a chemical adjustment. You have levers you can actually pull.
You have agency.
Exactly. Let's summarize the incredible ground we've covered today. We started with the accidental birth of the monoamine myth, those 1950s blood pressure and tuberculosis side effects that made us mistakenly reverse engineer the chemical imbalance theory.
Which sent us down a decades-long detour.
Truly. Then we explored how antidepressants actually seem to work through this slow, structural rewiring of neuroplasticity, not a quick chemical top-up. We uncovered the truth about dopamine, that it's driving reward prediction errors and motivation, which explains the crushing apathy of anhedonia.
And we looked at the rapid glutamate revolution with ketamine, acting like a circuit breaker to force immediate new connections.
Yeah. And as we wrap up, I know there is one final fascinating concept from the cutting edge of this research that you wanted to leave the listener with.
Yes, it builds on everything we've discussed, and it's called psychoneuroimmunology.
That is quite the mouthful. What does the immune system have to do with our mood?
It is the study of how your body's immune system directly communicates with your brain chemistry. There's growing, really compelling evidence that physical inflammation in your body triggers the release of immune signaling proteins called cytokines.
Okay, and what do the cytokines do?
These cytokines can actually cross the blood-brain barrier and actively suppress serotonin function and blunt dopamine release.
Oh, wait, so a purely physical inflammation response, maybe from a poor diet, an autoimmune issue, or a latent infection, can chemically mimic or cause severe depressive symptoms in the brain.
Exactly. It offers a completely complementary explanation for some cases of depression. It has nothing to do with a baseline chemical deficiency and everything to do with how the brain reacts to the body being under physical duress.
Think about that for a second. The next time you are feeling profoundly down, could your brain chemistry actually be responding to hidden inflammation in your body?
It completely shatters that idea of the clean binary X-ray we talked about at the start.
It really does. You aren't just a simple engine that needs more air in the tires. Your brain and your body are not separate entities. They are beautifully, complexly intertwined. It's a living ecosystem, not a machine. Thank you so much for joining us on this deep dive. Keep asking questions, keep challenging the simple narratives, and we will see you next time.